next speaker grew up in a farm, milking cows and driving tractors, but he stayed up late at night teaching himself how to program. He has been writing code since then for 30 years, and now he's here to talk about the value of large language models. Everyone, please welcome Travis Frisinger.
Awesome, thank you all. Much better than milking cows. I did grow up on a farm, absolutely. Well, I'm here to talk about the value of LLMs, or why stupid machines are smarter than you think, or why prompting feels like magic but isn't. Briefly, just a little bit about me. I'm the technical director of artificial intelligence at Eighthlight. My experience with AI prior to LLMs came mostly from natural language processing in telephony systems. Today, rather than focusing on model building or development, my experience lies in practical real-world applications, covering a broad range from AI governance to LLM ops to just about everything in between. So this isn't just a lecture, it's a story of a quest to understand a feeling and trace the structure beneath it. So this talk is really a top-down effort of my exploration of the value of LLMs. So let's take a step back. For me, this journey starts when GPT 3.5 came out. I believe that was around November 2022. If it wasn't, that's when my first experience was. I don't think it was shortly after it was released. And I was a little hesitant. I mean, I was like, okay, you know, I've used chatbots. I know the experience. I know IVRs, all that fun stuff. But, you know, there was a little bit of a difference here. Not just the media blowing things up. There was a fluency, kind of stunned the world how human-like it sounded, which resulted in a surge in public interest. There was a sense of general purpose utility. Now, I get, you know, the BERT models and transformer models had existed for a while, but this was really the first time we were starting to see some of these behaviors. That utility became the backbone of countless tools, is the backbone of countless tools. It was the first taste of coherence. Things felt fluid, collaborative. And the era of prompt engineering began, which is funny because now we're talking about how prompt engineering is more of a skill than maybe a separate role. The bad was brittle. There was a surface level fluency. It often collapsed on edge cases, logical reasoning, multiple steps. Prompt sensitivity. Small wording changes could dramatically change outcomes, revealing instability beneath the surface. Obvious memory limits with context. Shallow reasoning. And it felt a little overhyped at the end of the day. So I was like, okay, that's cool. Thanks for playing. I've checked out the latest round. I'm good for a while. Then GPT-4 came out. I believe that was around January the following year, 2023. Right around this time, I started interacting with it a little bit more. Microsoft published their Sparks of Artificial General Intelligence, early experiments with GPT-4, which it might have been overhyped. I'm going to say it was overhyped. We are no more closer to AGI than we were then, but it started people thinking. Not only was Microsoft publishing research on what is this thing we're all feeling, Ethan Mollick as well was approaching this from a lens of how to apply it to the educational realm of education as well as everyday work. So I wasn't alone. This feeling was real. There was something there. And I guess in my own words here, I felt my brain tingle as the words aligned effortlessly. It's the moment when the AI responses seemed to transcend mere just text generation and displayed something eerily similar to comprehension. By no means am I insinuating that there's cognition here, but there was an understanding, there was something, there was a feeling, there was a utility that I just couldn't let go of, and I didn't know why. So I felt the need to continue exploring. But before I did, I thought it was really insightful to kind of take a moment and step back and understand, what was a bit different about my interactions compared to what everyone else was talking about. They were all in this, prompt engineering train and structuring your prompts the right way. And I was like, the journey is the prompt. never treat my first one as the right one. It was more about iteration and refinement and like continuing to interact. I just was never going to get a single shot thing. I did try. I did play, tried to lean into some of the hype, just never got that experience to come through for me. So, me being me, I decided, hey, feels like there's a pattern here. It feels like there's something else that I really want to dig into. So I was like, I need some experiments. I need some way of further understanding this, not just casual chatting with the chatbot and kind of seeing its responses and embracing that feeling, but really being more of a scientist, trying to structure a series of experiments to dig into this. So the first one I did was live streaming. This was not my go-to. I talked to some colleagues about how could I continue to pursue thought leadership. She'd worked with a variety of people in the industry who have become quite proficient in thought leadership, and she's like, just start live streaming yourself. It's low friction, just babble on about your ideas, get out there and play. So I was like, okay, cool, I'll do that, I guess. So I started off with what I know, programming, and I started interacting with ChatGPT as a paired programming partner. This was almost 2 years ago. Live experimentation, I'd fire a stream up. I didn't know if anyone was going to join. Eventually, I ended up being a little more consistent with the branding and whatnot, and people would come. I think my max, I had like 20 people, and this is the middle of the workday. I'm just grabbing an hour in between meetings, hopping on with an idea, exploring it. No script, 2-line agenda, I'm going. So it taught me to be a bit more confident in exploring my ideas, building in public, being very open about what's failing, what's working, and I thought that experience in itself added a lot of value to this, just showing the art of the possible. We might come to have called this experience vibe coding. I called it chat-assisted programming at the time, because the goal was really to see, could I get the LLM to produce code that provided utility and added value to my life? Didn't need to be good. Didn't need to be fast. Could I do it? And I did. I ended up building a little custom GPT called WebCat, because back in the day, there wasn't internet access from GPT-4. I found myself copying and pasting web pages a lot to chat with them, which was annoying. So I got it to build about 150 lines of page scraping code in Python as an as-zero function. Eventually, over 2 sessions, I eked it out to actually being able to build the deploy pipeline and get it up. And I wired it all in, and it started working. Not great at first, obviously, but I could pull web pages in. I could say, at WebCat, let's pull the contents of this article in, and I could chat with it. So I wasn't copying and pasting anymore. I built something of value. I found some utility there. I was like, okay, cool. That's interesting. What else can I do? So I decided, hey, software's working good. Let's push into something that's maybe a little less familiar, not woefully unfamiliar, and that being content creation. So I decided, hey, let's start a blog, and let's see what we can do to collaboratively work with artificial intelligence to make content. So the coding wasn't working out so great. Tried something where it seemed to have a little bit more skill. And I collaborated with AI right from the beginning. I asked it, hey, what platform should I use? I have a server. I don't want to use WordPress. It recommended Ghost, walked me through the install instructions, showed me how to change the template. I got everything set up to go, and I was like, what do I write about? This is the thing I was worried about. And I had a funny little idea, so I popped it in and kind of worked with it to refine it into a little 2-minute article. So I was over the initial hurdle of like, what do I write about? And I continued to do this. I even brought this into my live streaming at some point, where I would get these article concepts and just explore them. I would go webcatting content. I would, start to try and frame the bigger pieces of the article. And with time, I learned this really detailed iterative technique of being able to kind of zero in, kind of rough out the fluffy AI fluff, and kind of work with what's good, what's bad, and really explore a thought landscape much quicker than I would have been able to do on my own. Really leaning into it to being more of a research assistant than maybe the writing side in those early days. So this quickly inspired me further. I was like, okay, cool. I can make code. I can write content. Can I make music? Which I did. I did. I made a metal album called Mr. Fluffle's Reign of Tiny Terror. It's about my cat. It's thematic, and for me, it was really this sense of being able to bring multiple tools together, being able to coherently design something start to finish that wasn't just text on a screen effectively. Right at this time, ChatGPT had, you can find it, it's out there. ChatGPT had started to bring out more refined image editing with their Dolly software. So prior to that, it was pretty much prompt, pick one, go, retry. There wasn't that iterative, collaborative sense to what was happening. So I discovered a tool called Suno, which did a lot of the music generation. I used ChatGPT to generate images for each of the songs, and then I used it to help generate lyrics and musical composition. Now, I do have a background in music. In between milking cows and programming, honestly, I learned piano. I taught myself initially, ended up taking lessons. So it's not an unfamiliar domain to me. So what I would do is I would take the Suno examples, and you could kind of see the prompts that they'd given, and I would feed them into ChatGPT's examples. And then I would tell it what I want, how to structure the song, and kind of go through a series of refinement. Plug it into Suno. They don't really have that iterative capability, so it was still a bit more like a slot machine, kind of just pulling the handle, hoping something good comes out, waiting for the right song to land, attaching the song, and uploading it. Now, with this experiment, I wanted to see, okay, cool, I'm seeing value in this, but are other people seeing value? You know, I had little traffic to my blog, but not a lot. So I made these songs, uploaded them to YouTube, and I told no one. I didn't advertise the fact. I just wanted to see, could this grow organically? Could I get 100 views on this crazy niche song concept? Within a month, I had 3,500 views, organic. People were finding it, they were liking it, they were commenting on it. I was like, whoa, hold on. There's real value here. I can really use AI, LLMs specifically, to go make things that are cool. So, you know, I had the two models. I had the ChatGPT model and the I want to say, it's like chip and something. It was another musically trained model, same kind of generative idea, blended together to produce something people found value in. So what did I learn from conducting all these experiments? Play like a kid. You know, don't overthink the art of the possible. Let your imagination run wild. And, you know, allow AI to unlock that creative potential. Suspend your belief, your practices, and explore a new way of doing things. It's a theme that, you know, has become really essential to me on this journey of understanding the value of LLMs. I think if I'd stuck in my rigid engineering mindset, I wouldn't have put the science hat on and went and just started exploring, seeing the art of the possible. But I wasn't satisfied. I was like, okay, cool, done some cool things. It's interesting, it's fun, people think it's cool. But you know, it feels like there's a pattern there. There's like a way of interacting. It's not just the domain. I've proven that I can scale out from just text and code. But maybe there's something about what I'm doing. So I was like, hey, I've run all these experiments. You know, maybe it's time to dig a little deeper. So with these experiments behind me, I took my lens back to traditional AI, trad AI as I like to call it. And I was like, what can I learn out of this space and pull forward into the generative AI space? So decision intelligence is one of the areas that popped out at me. It's effectively how we make decisions with traditional AI systems. It's a whole vast body of knowledge. It seemed pretty well aligned. And I knew, you know, from years of being an engineer in paired programming that I was likely exhibiting those types of behaviors as well. I was collaborating with this thing. There has to be some kind of like partnering happening. So I was like, okay, so what if I take all my chats and I start looking for these behaviors in that interaction? Could I find some way of naming the structure to what I'm doing? So I tried it. I vibe coded an analysis tool. Didn't touch the code once. I just literally went into, at this time, Cursor or Windsurf was good enough. And I said, hey, you know, how do I export my chats? Gave me the directions. I said, hey, cool, how do I like now take those chats and feed them into an LLM? It gave me the prompt. It gave me the code to do that. Now, none of this worked great the first time. That was not the goal. The goal was not to accelerate my learning with this. To accelerate my delivery. It was to accelerate my learning, to explore the art of the possible, to really lean into using AI as much as I could to find value. So I went through this it's a really long process, so I had to go through multiple stages of taking the chat history one by one, wrapping it in a prompt that looked for decision intelligence, looked for pairing behaviors. I ended up writing a 21-page case study on this. That was never my intention, but that's, I guess, what happens when you really dig into things and find it interesting. And it went through the analysis, the summarization, both quantitative and qualitative information came out of this. And what I realized is there was kind of a structured interaction occurring. It wasn't just, random, I'm having a good conversation. There was mechanics at play here that led to better results. Specifically, something I pulled out and named was the AI decision loop. It's in the paper. It's got a 5 kind of step process to it. I like to think this is my academic version. There's a small refinement I'll talk through in a little bit that kind of blends a few of the steps. But the idea is let's frame the problem up, define it, put the context there. That's your prompt engineering. That's where people kind of start and stop generally in their experiences. Because you got to give it the right information to operate. Then it's about generating potential. So in that prompt, you may ask it to take on different personas, kind of compare and contrast, to iterate options. Whatever you're going for, kind of frame it around your goal. You're bringing the intent to the system. The system doesn't have the intent. You need to make sure it's clear. Then once it's done, I go and I want to judge, I want to evaluate the quality of that. I may do that by asking it some probing questions. I may ask it things that are completely false and see if it's oh no, you're right. Just trying to sense check and poke at the output. Then I will go and validate that against the requirements or a larger body of knowledge if I'm in a really kind of regulated space. And then the important step of iterating and refining, kind of figuring out what it got right, what it didn't get right, reframing that next part of the conversation and continuing to iterate through the loop. What I find is that in my research, when I looked at my chat history, I did this about 62% of the time. Now, obviously, some of those queries are what's the capital of Paris, or other really just informational type queries, but a lot of them worked. All this chat history included all the experiments I had been doing up to this point. So this is where I think it gets interesting, because I find that folks that don't see the same level of value in the tool often do the kind of 1, 2, and out. Frame, generate, accept, move on. There's very little judging and evaluating and really deep attempts at iterating. I think AI-assisted tooling is bringing us into that journey more than it was, but it's still something to call out. There's a deviation there. If you just accept it, you're not going to end up with as good of results as if you really lean into it. So what did I learn from analyzing 2,500 of my own ChatGPT conversations? AI's true value emerges through active engagement, not passive acceptance. Iteration and refinement unlock creativity. And the more we engage with AI as a thought partner, the better our results become. It's not an autopilot, it's a co-pilot requiring direction. Okay, so I'd found something. Well, great, hurrah! I felt a little better, but still wasn't fully satisfied. I was like, okay, this explains the mechanics, but it still doesn't get at the underlying value creation mechanisms that I'm experiencing. Just give me a sec. So I still had questions. I still needed to expand this conceptual framework. This, for me, was really starting to look like coherence. It's a concept from natural language processing. It's often mistaken for cognition because we use coherence as a measuring stick to measure cognition. But there was mysteries. I still wanted to dig into this. The how and the why were a little elusive. But before I get to the further digging, I figured let's understand the lessons on the journey so far. My key takeaway was nudge and iterate. You frame, generate, judge, and iterate, kind of the condensed version of the loop. It's the process at the heart of every reliable LLM interaction. Like I said, 62% of the time I did that. In 97% of the time I did that and exhibited pairing behaviors, I ended up with a better outcome. So these steps don't just structure interaction, they create the conditions for coherence to emerge, for that higher level of utility than what we would typically experience in just kind of prompting and accepting. So I needed a new theory and a new paper. This is an 8-page case study that kind of digs a little bit more into the theory of coherence. It's inspired by a wide range of research. So I didn't just kind of pluck it out of thin air. I asked the LLM. I was familiar with a variety of research papers, and they all seem to be kind of pointing in this direction without specifically calling it out in most cases. Like the lottery ticket hypothesis. What else do we have? Attention and message passing and graph neural network analogies. Some RAG stuff coming out of Google, Anthropic's work on feature superposition and concept circuits. So really, not only am I doing this, I'm digging into the research, I'm consuming a lot of content. And obviously I'm using an LLM to assist me in doing this. I don't think there's any way a single human being could consume this level of things without collaborating. So before we get into the mechanics of the theory, let's take a moment to define what coherence is. It's relevant, meaning that the model's output feels topical, connected, and purposeful to the conversation. There's a consistency to it. It references the model's ability to maintain a tone, terminology, and structure across multiple turns. Now this is interesting. GPT-4 was not very good at this in the beginning, and in some cases, if you have to correct it on a term, it doesn't remain very good. Stability, a model can develop an idea under pressure rather than falling apart, so I may poke at it with alternative views, or I may ask it to dig deeper on something, and it doesn't just give me garbage, but it kind of reinforces it with value-adding perspective. I think most importantly to note, coherence is an emergent property of these large language models. Specifically, the case I'm thinking of is that the 4O's developed the ability to detect flying swoo, even though it's never been trained on any of that information. Cancer diagnosis, they can often detect them sooner. There's a variety of things that, it seems as though coherence is behind the scenes, that pattern alignment. And these properties are crucial for building trustworthy, reliable AI systems. So before we get down into some of the mechanics, we need to talk a little bit about components of the architecture, just because it'll make a lot more sense when I get there. So we've got, 5 major components here. The tokenizer, which breaks the input text into smaller units. The embedding layer that maps those tokens into high-dimensional vector space. That's where we take language and turn it into math, basically. The transformer, this is the attention portion of the stack. It's got many layers that shape the contextual relationships. Obviously, the neural network with its structure of weighted layers. This is where the learning knowledge lives. And the individual neuron, kind of responsible for encoding the data and contributing to the conceptual output. So how does the transformer drive some of this? Well, we've got the token embedding that breaks the words down into that vector space. You have the transformers weighting those relationships between all tokens simultaneously, self-referencing. You've got the multiple layers within the neural network, ultimately resulting in this really simple mechanic known as next token prediction. So effectively all it's doing is just trying to guess the next word in the sentence based on what's come before it. Okay, cool, that's interesting. So you got this transformer driving this knowledge base and somehow reasonable results come out. These attention patterns aren't storing the meaning. They're shaping it. So unlike knowledge bases, LLMs don't retrieve facts, they assemble structure into something that feels like meaning. Attention isn't about memory, it's about resonance. Tokens influence each other through weighted relationships. Meaning arises from those weights as they stabilize into something that aligns with our intent. This is specifically why I say AGI is not achieved or even achievable at this point. LLM can't generate its own intent. It's just sitting there waiting for us to bring its intent. our intent, to help drive the machinery, to drive the mechanisms. The second, it can figure out how to derive its own intent. Yes, we're at AGI. But until then, absolutely not. So more mechanically, or more like philosophically, I guess, how do the mechanisms come together? Well, this concept I like to call force vectors. So basically, a prompt is a directional force, helping navigate that high-dimensional space. This is where engineering metaphors start to matter a little bit more. We're not prompting a chatbot, we're pushing it. Each prompt nudges the model through latent space, full of structure, association, and tension. What comes out isn't a lookup, it's the trajectory of your prompt that your prompt initiated. So each prompt sets a specific direction where the AI aligns with the patterns. Because AI does not think in the traditional sense. It simply follows these directional vectors to find coherent, structured, useful outputs. This was inspired by Anthropic's tracing thoughts research, which looked at how coherent activation pathways emerge in LLMs. Along with Ethan Mullick's research, where he discusses LLMs' great prowess in generating coherent narratives and pattern continuity, along with other reams of research as well. There's this reference slide at the end. Okay, cool. So you got these neurons, they're storing information. You got this transformer that's like driving the structure, helping sculpt the meaning. But that doesn't quite line up. There's still a missing piece here, right? So like if a neuron's holding the understanding of what a cat is and another one a dog, how does it create the opportunity for coherence? How does it emerge with new ideas? Isn't it just parroting back what it heard? I don't think so. There's this concept called superposition, where an idea isn't encoded into a single neuron. It's spread out across multiple neurons, and multiple neurons can encode multiple ideas. And this is where things start to get funny. It allows a network to represent complex ideas with fewer parameters, packing more nuance into the same space. As context accumulates, the network teases apart the relevant meaning and collapses ambiguity into coherent outputs. Meaning isn't retrieved, it's constructed on demand from distributed sparks of possibility. Okay, well, what is that going to look like? How does it get from prompt to output? Well, the idea is that you've got this context, you've got this prompt, and it's going to go into the system. You're going to have the transformer chiseling away. You're going to have this neural network that it's navigating. And at the end of the day, these forces fire up these latent subnetworks, these clouds. They light up these regions of meaning. So think narrative, logic, structure, instruction. Here I've got freedom and storytelling. They're not pre-wired, though. These emerge during training. And there's specialized patterns that activate when context calls for them. So typically people think, oh, the whole thing's just one giant brain. But like our brain, it's compartmentalized. It's got different areas of specialization. And we're starting to see that same behavior emerge. That's what's happening here. So because superposition is stored a concept across multiple neurons, you're going to activate different concept clouds as that idea comes into existence. So what does this mean? This means that there's a new kind of utility. I would theorize that most AI or LLM theories focus on the idea of compression. How efficiently information is stored within the network. More like a database with smarter indexes. I'm proposing that, while information is stored, it's about reconstructing the ideas. The utility isn't a recall, it's the ability to recreate the essence, the ness-ness of the thing. The tone, the structure, the intent, the rhythm all make something that feel right. That's why they hallucinate, and it will sometimes still feel correct. They're completing the pattern. They're not fact-checking. This is where I think if we look at it from a perspective of cognition, you would expect it to know how to correct itself. Where if you look at it from a perspective of coherence, it's following the pattern that's been put down as it's been built. So more specifically, patterns versus thinkings. LLMs don't think, they pattern match. And we rely heavily, like I said, heavily on coherence to judge something as intelligent. So AGI is going to require the reconstruction of abstracting, grounding, goal-directed reasoning, a whole lot of things we're trying to explore in the agentic space. Not to say that it's unachievable. I do believe coherence is a precursor to cognition, but I don't think cognition is a standalone emergent property of these tools. I think we need to figure out better ways and better techniques to combine things to get there. So I mentioned hallucinations. Well, I don't see them as a bug in the system. I think it's a feature of the coherence as an emergent behavior. There's still something to be dealt with, don't get me wrong, but they're not just like the machine misbehaving. It's doing the thing it's supposed to be doing. They reveal an inner working of the coherence mechanism, inner models. So when the models lack sufficient constraints, they naturally pattern, match, and extend them into plausible narratives, even if factually incorrect. So models typically hallucinate in predictable ways given the same context, following their internal logic and coherence vectors. Studying the nature of these hallucinations can provide valuable insight into how coherence operates without truth constraints. This is a very big area of research right now, from what I'm reading and hearing. We're really trying to figure, well, the researchers, I'm not, trying to figure out yet, probably someday, figuring out how you go about removing hallucinations. How do you deal with them? What do you do with them? Well, I mean, as we all know, RAG is a technique to try and limit hallucinations. Now, why I think they operate so well is you're adding that, factual anchor into the vector space. You're saying, hey, these are the things you really should be focused on in your coherency narrative. I think to some degree you could even get to gravity well level pulls. But it's the structural scaffolding. It's the shape that the coherence uses to unfold and follow. For those of you that don't know, RAG is a design pattern where you augment a language model's generation with retrieved external context. You're going to inject that context into the prompt, usually from your own data, to reduce hallucinations, increase factuality, and allow domain-specific reasoning. Often people kind of stop and say, oh, I've got a vector database that I ran things through, and I'm going to take those embeddings, and it's using embeddings, and I'll find magic. Well, it's a high-dimensional space. It could match on 60 or 62 vectors, but then the two that are off really throw you into the wrong direction. I'm more of a fan of a polyglot model. I've got a deep background in search as well, so I don't think vectors are the whole story. Vector databases are the whole story to solving this, just as a side note. So instead of hoping the model remembers, or you're fetching the material just in time. Think of it like giving the model exam notes just before the exam. It's got something to work off in the moment. And I'd say for me, mapping kind of my theory back to this and resolving it, because it was an unresolved piece. I was like, okay, well, how do hallucinations fit into this coherency model? It was a turning point, realizing that treating them as anchors, treating them as the grounding to navigate through helped close that loop, help me understand that, okay, it's an emergent behavior, it's not a bug. Okay, cool. Well, how is this useful? How can we start to think about these components in a more engineering-focused perspective, a little less theoretical, a little less philosophical? I've got a 3-layer model I like to frame things around. Layer 1's the latent space. This is the internal model structure, the concepts, the weights, the activations. Layer 2 is interesting. This is where we start to layer in the RAG concepts. You're going to have some retrieval mechanisms, APIs. Tool use, I'm not so sold on tools as a computer operator perspective, maybe as like an extension to fetching information. That's maybe a spicy opinion, I don't know. And then what I'm calling the conversational interface. This is more than just a dialogue between you and a machine. Remember, this is the prompts, the grounding that you may have brought in beyond the RAG. This is where the human intent aligns with the machine. This is where the context becomes super important, how we manage it, what we bring through. Great story about this. I've got a friend working in a highly regulated, highly secure environment. He's still using AI to do code gen. He had to do it all himself. He had to bring a small model in, get it verified. He had to, little templates for some common code snippets. But the fun thing that stuck out to me is like, I had to gaslight the thing. I was like, what do you mean? He's like, I had to go back into the chat history and just pretend that I'd given it the right facts or like bizarre alternate facts to get it to consistently give me the output. I was like, that's fascinating. So that's why I call this the conversational interface. There's some tweaking, some adjustment beyond just the model parameters that you may need to experiment with to get the results you're looking for. And it's working well for him. It's fantastic. His team's really accelerated their delivery, and he's happy with it. I do have a podcast somewhere for Eighth Light, Fuse and the Flint, if you want to hear more about it. So how do we engineer with coherence in mind? Think of prompting more as an interface design. Structure prompts as part of a loop, not once off. Use consistent framing to stabilize tone and guide output. Grounding equals coherency anchors. Of course, use RAG to steer this thing. Be really mindful how you tune that in. Most importantly, I think if you take one thing away from this engineering slide, we design for emergence, not control. And this is where I think we go wrong with a lot of what we try to do. And this is that tool use comment. It's not about giving it something or trying to control it. It's about understanding how to work with the coherence and the non-deterministic nature of it. Frame, generate, judge, iterate. Even in your systems. Even when I vibe coded some of my analysis, I ended up doing pieces of this just to make sure that things were lined up and working. And don't forget coherence is a quality signal. Watch for breakdowns in tone, structure, flow. If you're deep into this world, you're probably running some kind of LLM ops platform. It's got a bunch of evals. Look to build evals that maybe check coherence as well as accuracy. It might be an indicator, it might be a signal. I haven't had the time to research that deep yet. It's probably the next thing I'm going to dig into. So how does this come together? What's the stupid machine? Well, the stupid machine is the human and the AI synergy here, right? LLMs aren't intelligent, they're coherent, and that's their superpower. The magic happens in that collaborative dance. The human provides the grounding, the AI offers the pattern recognition, the human guides, and together you enter that loop, that dance. I've live coded with ChatGPT, I've co-written music, I've built frameworks with LLMs, well, small. But it wasn't just the output, it was the loop. The back and forth that surfaced better ideas, tighter riffs, stronger code. The model brings coherence, I bring the grounding, the aesthetic, and the strategic aim. That's what makes this machine powerful, not their intelligence, but their compatibility with our own. So this isn't just artificial intelligence, it's structured resonance, and it gets better when you drive it. Coherence is the machine's superpower, judgment is yours. Ultimately, I think of this as a high-dimensional mirror. We're not talking to a thinker, we're standing in front of a mirror with 8,001 dimensions. The machine doesn't understand you, it resonates with you through structure, not thought. And sometimes what it reflects back is sharper than what you gave it. So what's the takeaway here? Prompting is the start, looping is the system. Embrace the machine's stupidity by structuring loops of intent, context, and critique to collaborate smarter and produce more coherent outcomes. Obviously, I've got some theory limits here. Superposition is likely not the whole story, it's just where the research is currently. It's constantly evolving, and coherency does not equal correctness. They are two different things. You will want to check for both. Thank you very much for listening. If you want, there's my link tree. You can get to LinkedIn, my blog, my album, any number of things you may find interesting.
Thank you very much for this. I believe we have time for some questions, if there are any. Yeah.
So when you were talking about the hallucination aspect, that got me thinking, if a hallucination output is something that is fully coherent, but not correct, is there an example of an LLM hallucinating an API that in reality should be there?
Oh yeah, I've seen that happen so many times.
So So it's like, oh, we actually should implement that.
Yeah. It's just like, oh, this should have been an extension of this concept. Like, oh, sorry, it's not there. Yeah.
Oh, that's crazy.
Yeah, when I vibe coded my analysis, it did it to me a lot.
Wow, that's
I agree. Any other question? Okay, thank you very much.
Thanks.